Hello friends, myself SUBHASH NAGARSE from Sri Digambar JAIN GURUKUL High School, Solapur. I shall welcome to all of you in the session of 9th Mathematics Part 1st. The topic is Polynomials Part 9. In this session, we are going to discuss with factor theorem and the practice set 3.5. Friends, in the previous session of this Polynomials Part 8, we have been discussed with the following important subtopics, that is the remainder theorem and the problems from the practice set 3.5 that are based on the remainder theorem. Friends, today in this session we are going to discuss with the factor theorem. So, factor theorem, if 21 is divided by 7, then remainder is 0. Therefore, we say that 7 is a factor of 21. In the same way, when a given polynomial is divided by the divisor polynomial and if the remainder is 0, then we say that the divisor polynomial is the factor of the dividend polynomial. Friends, the statement of this theorem is like this: if p of x is a polynomial of degree n greater than or equal to 1 and a is any real number, then first x minus a is a factor of the p of x if p of a is equal to 0, and p of a is equal to 0 if x minus a is a factor of p of x. Let us prove this one. We know that dividend is equal to divisor into quotient plus remainder. It could be written as p of x is equal to x minus a into q of x plus p of a, where here p of a is the remainder. If p of a is equal to 0, then we can say that p of x is equal to x minus a into q of x. Friends, which shows that x minus a is a factor of p of x. Second, since x minus a is a factor of p of x is equal to x minus a into g of x, where same polynomial for g of x. In this case, p of a is equal to a minus a into g of a, which will be equal to 0. A minus a is 0, 0 into g of a is 0 itself. Let us start with the practice set 3.5. Already 6 problems we have been discussed. Let us start with problem 7. Use factor theorem to determine whether x plus 3 is a factor of x square plus 2x minus 3 or not. We'll start with the solution. Let p of x is equal to x square plus 2x minus 3. Put x is equal to 3 in the above polynomial. We will get a divisor is equal to x plus 3. Therefore, we can take here x is equal to minus 3. And the remainder is p of minus 3. Therefore, p of x is equal to x square plus 2x minus 3. Therefore, p of minus 3 is equal to minus 3 raised to square plus 2 into minus 3 and minus of 3. Therefore, p of minus 3 is equal to minus 3 square is 9, minus 2 3s are 6, minus of 3. Therefore, we will get p of minus 3 is equal to 0. Therefore, by factor theorem, we can say that x plus 3 is a factor of x square plus 2x minus 3. We start with the next problem number 8. If x minus 2 is a factor of x cube minus mx square plus 10x minus 20, then find the value of m. Friends, here let p of x is equal to x cube minus mx square plus 10x minus 20. Here x minus 2 is a factor of x cube minus mx square plus 10x minus 20. By factor theorem, here the remainder is equal to p of 2, which is equal to 0. Since it is a factor, therefore p of x is equal to x cube minus mx square plus 10x minus 20. Therefore, p of t is equal to 2 raised to square cube minus m 2 raised to square plus 10 into 2 minus 20. After simplification, but we know that p of t is equal to 0. Therefore, we can write, therefore 0 is equal to 2 cube is 8 minus 4m plus 20 minus 20. Therefore, here 0 is equal to m minus 4m. Therefore, 4m is equal to 8. But therefore, m is equal to 8 upon 4. Therefore, you are getting m is equal to 2. Friends, let us see the next problem number 9. Here, by using factor theorem in the following examples, determine whether q of x is a factor of p of x or not. The first problem is p of x is equal to x cube minus x square minus x minus 1, and the q of x is equal to x minus 1. Friends, let this p of x is equal to x cube minus x square minus x minus 1, and divisor is equal to q of x, which is equal to x minus 1. Therefore, we have to take x is equal to 1. By remainder here given p of 1, therefore p of x is equal to x cube minus x square minus x minus 1. Therefore, P of 1 can be written as, put the value of x as 1 raised to cube minus 1 square minus 1 minus 1. Therefore, we'll get 1 cube is 1, 1 square is 1. So, 1 minus 1 minus 1 minus 1. Therefore, you will get the value as minus 2. Therefore, P of 1 is not equal to 0, since P of 1 is coming up minus 2. Therefore, by factor theorem, we can say that x minus 1 is not a factor of x cube minus x square minus x minus 1. Let us see one more problem, that is P of x is equal to 2x cube minus x square minus 45 and Q of x is equal to x minus 3. Friends, let here P of x is equal to 2x cube minus x minus 45. Therefore, we can write here that divisor is Q of x, which is equal to x minus 3. Therefore, x minus 3 is equal to 0 means x is equal to 3. We have to take remainder is P of 3. Therefore, P of x is equal to 2x cube minus x square minus 45. Therefore, P of 3 will be equal to 2 into 3 raised to 3 minus 3 raised to square minus 45. Here x is replaced by 3. Therefore, 2 into 3 raised to 3 means 27 minus 3 square is 9 minus 45. So, here 27 2s are 54 minus 9 minus 45. Therefore, the result is 0. Therefore, P of 3 is equal to 0. Therefore, by factor theorem, we can say that x minus 3 is a factor of 2x cube minus x square minus 45. Let us see problem number 10. If x raised to 31 plus 31 is divided by x plus 1, then find the remainder. Friends, here let P of x is equal to x raised to 31 plus 31. Divisor is x plus 1. Therefore, we have to consider x plus 1 is equal to 0 means x is equal to minus 1 we have to consider. Therefore, by remainder theorem, remainder is equal to P of minus 1, that we have to consider. Therefore, P of x, it is given x raised to 31 minus plus 31. Therefore, P of minus 1, replace x by with minus 1. P of minus 1 is equal to minus 1 raised to 31 plus 31. Friends, here you can see that minus 1 raised to 31. 31 is an odd number. Therefore, the resultant will be minus 1 only. Minus 1 plus 31, which will result into 30. Therefore, P of minus 1 is equal to 30. Means remainder is here 30. Let us take problem number 11. Show that m minus 1 is the factor of m raised to 21 minus 1 and m raised to 22 minus 1. Friends, we will start. Let this P of m is equal to m raised to 21 minus 1. Divisor, it is given m minus 1. M minus 1 is equal to 0. Therefore, m will be 1. We have to consider. Remainder that will be here P of 1. So, we will continue. P of m is equal to m raised to 21 minus 1. Substitute here m is equal to 1. Therefore, P of 1 is equal to 1 raised to 21 minus 1. Here 1 raised to 21, it is 1 only. Therefore, P of 1 is equal to 1 minus 1. Therefore, you will get the result P of 1 is equal to 0. Therefore, by factor theorem, we can write that m minus 1 is a factor of m raised to 21 minus 1. Now, second, let P of m is equal to m raised to 22 minus 1. Divisor is m minus 1. Therefore, we can write m minus 1 is equal to 0. Therefore, we have to take m is equal to 1. Here the remainder we have to consider is P of 1. Therefore, P of m is equal to m raised to 22 minus 1. Now, substitute m is equal to 1. We can write P of 1 is equal to 1 raised to 22 minus 1. So, 1 raised to 22 is 1 only. Therefore, P of 1 is equal to 1 minus 1. Therefore, we will get P of 1 is equal to 0. Friends, by the factor theorem, we can write that m minus 1 is a factor of m raised to 22 minus 1. Now, let us consider problem number 12. If x minus 2 and x minus 1 by 2 both are the factors of the polynomial nx2 minus 5x plus m, then show that m is equal to n is equal to 2. Friends, we can write that P of x is equal to nx square minus 5x plus m. x minus 2 is a factor of nx square minus 5x plus m, it is given. Therefore, by the factor theorem, here p of 2 is equal to 0. Therefore, p of x is equal to nx square minus 5x plus m. Now, substitute x is equal to 2. Therefore, p of 2 is equal to n into bracket 2 raised to square minus 5 into 2 plus m. Now, we can write p of 2 is equal to 0 given. Therefore, 0 is equal to 2 square is 4, means n into bracket 4 minus 5 2s are 10 plus m. Therefore, we can write 4n minus 10 plus m is equal to 0, equation 1. Also, x is equal to half 1 by 2 is a factor of nx square minus 5x plus m. Therefore, by the factor theorem, we can write that p of half is 0. Therefore, p of x is equal to nx square minus 5x plus m. Write the value of x as 1 by 2. Therefore, p of 1 by 2 is equal to n into bracket half raised to square minus 5 into n by 2 plus m. So, friends, but p raised into bracket half is 0. 0 is equal to n into 1 by 4 minus 5 into half plus m. Therefore, we can write that 0 is equal to n minus 10 plus 4m, multiplying both side by 4. Therefore, you will get n is equal to 10 minus 4m, second equation. Now, in this second equation, the value of n is equal to 10 minus 4m. We substitute in equation 1. Therefore, we will be getting that 4 into bracket 10 minus 4m minus 10 plus m is equal to 0. We will solve this one. 4 into 40 minus 4 4s are 16m minus 10 plus m is equal to 0. Therefore, here we will get minus 16m plus m, that is minus 15m plus 30. 40 minus 10 is 30 is equal to 0. Therefore, minus 15m is equal to minus 30. Therefore, you can write that m is equal to minus 30 divided by minus 15. After simplifying this, we are getting m is equal to 2, equation 3. M value we calculated. Now, substitute this m is equal to 2 value in the equation 2. We will get that n is equal to 10 minus 4 into bracket 2, which will be 10 into 4 2s are 8. Therefore, we can write n is equal to 2. It is equation 4. So, from this equation 3 and 4, we can write m is equal to n is equal to 2, that which we have to be proved. Now, we will consider problem number 13. If p of x is equal to 2 plus 5x, then find the value of p of 2 plus p of minus 2 minus p of 1. Friends, let this p of x is equal to 2 plus 5x, it is given. Therefore, p of 2 can be written as 2 plus 5 into 2. So, it will be 2 plus 5 to the 10. Therefore, we will get that p of 2 is equal to 12. Friends, p of x is equal to 2 plus 5x, it is given. Now, p of this value 2 is, we can write 2 minus 10. Therefore, p of minus 2 is equal to 2 plus 5 minus 2. So, it would be 2 minus 10. Therefore, we will get p of minus 2 is equal to minus 8. Secondly, p of x is equal to 2 plus 5x, it is given. Therefore, we can write that p of 1 is equal to 2 plus 5 into 1. Therefore, it will be 2 plus 5. That will be p of 1 is equal to 7. Friends, as here, therefore, p of 2 plus p of minus 2 minus p of 1 is equal to 12 plus into bracket minus 8 plus minus 7. Therefore, we will get that p of 2 plus p of minus 2 minus p of 1 is equal to minus of 3. If p of x is equal to 2x square minus 5 root 3x plus 5, then find the value of p of 5 root 3. Friends, let here p of x is equal to 2x square minus 5 root 3 x plus 5. Therefore, p of 5 root 3 is equal to 2 into 5 root of 3 square minus 5 root 3 into bracket 5 root 3 plus 5. Therefore, 2 into 25 into 3 minus 25 into 3 plus 5. Therefore, here 2 into 75 minus 75 plus 5 will carry the product. 75 into 2 is 150 minus 75 plus 5. Therefore, we will get that 80. 150 minus 75, that is 75 plus 5 is 80. Therefore, you can write p of 5 root 3 is equal to 80. So friends, what we have been discussed till today in this session. In this session, we have discussed on the following subtopics of this chapter, that is the factor theorem and the problems from the practice set 3.5 that are based on this factor theorem. So friends, will you try this one? Using the factor theorem, verify that x plus 4 is a factor of p of x, which will be equal to 5x4 plus 16x cube minus 15x square plus 8x plus 16. Prove that x plus 1 is a factor of p of x, x square plus 2x plus 1. Use the factor theorem to check if x minus 4 is a factor of x cube minus 9x square plus 35x minus 16. Use the factor theorem to prove that x plus 2 is a factor of x cube plus 4x square plus x minus 6. Find the value of given k, given that x plus 2 is a factor of the equation 2x cube minus 5x square plus kx plus k. Friends, you should not forget the famous words of Shakuntala Devi. Education is not just about going to school and getting a degree. It's about widening your knowledge and absorbing the truth about life. Friends, if you like this video, please subscribe and share with your friends, and don't forget to press the bell icon. With these words, I would like to say thank you.